Welcome back to First Look Asia. You may not notice it, but there are systems in your car that work really hard to keep you safe.
Just what are some of these safety systems and why are they so important? Cruise Control finds out.
Hello and welcome to Cruise Control, and today we're looking at specific safety systems that help the driver stay in control. From anti-lock braking system to electronic stability control, most new cars nowadays come fully equipped with these features. But how do they work exactly?
We found out here a specially built course to test some of these safety features, simulating real-world conditions in a controlled environment.
And Mother Nature has decided to make this course extra challenging for us today. But to help guide me through it is Ami. You've been an instructor for over almost 20 years now.
Yep.
What can we expect to see here then?
Well, you can see right behind us, slalom rail, which usually a vehicle would not like to change direction quickly. So there's a bit of challenge for the car to basically to maneuver the car around the slalom course. And we also have basically a staggered slalom, which is like a quicker slalom, which is like different staggered gates around it. And also a braking box down there, so you need to stop in the box. So all the element of the features of the car is actually into the fray of running on this course right now.
This kind of course that we have here, is it the kind that it's normally used for quality control of cars?
I would say it's more for during development stages. All right, this car has been to stringent, basically development phases that that gone through all these things by the engineers who engineered the car. So these are I would say the usual way of them testing the car before it's passed out over to the public.
Okay, well, I'm looking forward to putting these sensors to the test, and looking forward to your instruction. Let's go.
Thank you.
So the first exercise that we're going to be doing is emergency and evasive braking, and what this will do is it will test the brakes on this car as well as the anti-roll bar, amongst other systems.
Right.
Okay, well, let's give this a try. I accelerated to about 50 clicks per hour, heading towards some strategically placed cones. The moment I was told to, I hit the brakes. I killed the cone.
Yeah. What you did there, because this is hand-eye coordination, because your eyes is telling you there's an obstacle. So immediately when you brake, you actually did not observe the obstacle to the left. You just immediately turn.
Okay.
So you killed the cone on the left-hand side. It's like you're turning a bit too early. So you have to gauge that.
So, the brakes worked well, but I didn't. It took me a couple more tries to get the hang of it.
That's it.
The disc brakes did bring the car to a rapid stop, and the anti-roll bar helped prevent the body from rolling too much. But in a sudden braking situation, it helps to have good hand-eye coordination and quick reflexes.
The next exercise is going to showcase ESC, or what they call electronic stability control. As you can tell from the name, it implies that it will help control the car and also keep it stable. Both elements, I think, very, very important in driving. How does this work?
Electronic stability control, work in tandem with the ABS. It has wheel speed sensors. So what it detects, because let's say the car is moving at 80 km per hour, all four wheels are supposed to be turning at 80 km per hour, for instance. But when it senses that one wheel is actually spinning faster than the other, so that means the car is actually losing control, it's slipping somewhere. So what it does is actually basically individually braking to stabilize the thing.
What's the benefit of it then on the road?
Safety, It's mainly safety, because otherwise you tend to lose control of the car, because the moment you try to turn when the car is refusing to turn, you will totally lose control to the direction you need to go. This is where the ESC will come to the picture to help you to direct back to the point that you need to turn.
Time to test this out on a slalom course.
Usually a car would not be comfortable doing this.
By steering the car around the cones, it forces the body to roll hard either way. In the extreme, the car's wheels can lose grip and lift off. What the electronic stability control does is sense when this happens and brake the appropriate wheels. This way, the car always remains firmly planted on the ground, ensuring you're fully in control.
I gotta say, that was thrilling, and we've now seen how these systems work while you're on the move.
Yes.
Let's take a look at one where, that helps us when we brake.
Yes. Yeah.
now for our next exercise, and we've had to change cars for this one, and it's to test out the anti-lock braking system, or the ABS. And this helps to prevent your tires from locking every time you brake and ensure that your car doesn't spin out of control. So how does this exercise work then?
We will be braking on two different split level of basically traction. Your right tires will not have any traction, your left tires will have some traction. This is like simulating like you're on the road, and suddenly you have two tires on the grass, and suddenly you have to brake in an emergency situation, right? When the car is not fitted with ABS, what happens with the different grip level, one side of the tire will have more traction and will just spin it around.
Well, so our next exercise, first without ABS.
Accelerating as fast as possible, I braked hard when we hit the dual surface.
That's 180 spin.
180 spin.
180 spin with a speed of slightly more than 40 km.
That's not very fast.
That's not very fast, but still, you see,
Yeah.
when the car is not fitted with ABS, this can happen to you.
Okay, well, let's see what it's like with ABS. And so we'll change cars now to a car with ABS.
Yes.
So now we're back in the car with ABS. What is the expected outcome for this one then?
In this one, what I want you to do afterwards is you're going to be breaking the straight line. And even better, I want you to lift off your hands from the steering wheel.
What is the practical application of that then?
You will notice just now, right, with the car with the ABS, the tires are simply locked up.
Yeah.
And with the different grip level, the car is spinning around. With the ABS basically activated, you can brake safely even with different grip level.
Yep.
All right, and even without needing to work on the steering wheel,
Yep.
the car will be still be tracking straight.
All right, let's go.
I did like before, braking hard as we hit the dual surface. This time, taking my hands off the wheel, expecting the car to swerve. It didn't, just jutted to a straight line halt. And that's the anti-lock braking system at work, rapidly applying and releasing the brakes at a rate of 16 times a second. This prevents the wheels from locking up and skidding out of control as we did before. A great feature, now standard in almost all cars.
As we've demonstrated, there are several safety systems in place to ensure that you have a safe ride. But remember, the best one is still the one who's behind the wheel. So until next time, remember to keep your eyes on the road and stay safe.
And that was Jeffrey Lip trying out safety systems that can be found in most new cars today. You can follow Jeff, that's with a G, and his motoring exploits on Twitter at JeffreyLipCNA.
Next week, we cross over to Cambodia and take what's normally a city slicker off the beaten track. Be sure to stay tuned for that.
Okay, time for a short break now. World News is next. Plus,
what we understand as design, creativity, art, fashion, music, we're still being schooled in Western philosophies.
Young, talented, creative, pragmatic, and never afraid to speak her mind. We sit down for a beverage with fashion designer Priscilla Ong Shanmugam on Coffee with the Boss in the next hour.